So in this question, a crate is being pushed through the alley by two crossroads students. One pushes with a force of 250 and the other with a force of 300 newtons. We're going to assume that they're both pushing in the same direction. Obviously, they're not at odds with each other. So we can draw these two forces. One of them is being... So what are the... Again, if we're going to answer this question, what is the net force acting on the crate? We have to sort of decide what are all the forces acting on the object. Something we haven't talked about yet is the idea of balanced forces. And we're going to get into this more when we talk about Newton's first law. Balanced forces. We kind of alluded to it in the previous problem when we said that the forces acting on me when I'm falling through the air after the parachute opens are balanced. And what generally tends to happen is when an object is moving in one direction, the forces are balanced in the perpendicular direction. So in the case of the vertical in this problem, we do have the force of gravity. We always do, right? Fg, but it is balanced by the support force that the ground is exerting on the crate. So there's a normal force acting up, and we can say that those two forces are exactly equal because the crate is not moving. It's not floating off the ground. It's not crashing into the ground. So for the purposes of this question, we can kind of ignore those forces and focus on the horizontal ones. So then we've got the two pushing forces, and I'm still going to draw them as if they come from the middle of the... I prefer you to draw your forces radiating out from the middle of the box or from the object. So, oh my goodness. So, here's one force, and that's 250 newtons. Here's the other force, it's 300 newtons. And then it says there's a force of friction, and the friction opposes the motion, so it's backwards of 500 newtons. So this is the force of friction. This could be the first applied force, this could be the second applied force, like that. And so since what we're saying is in the vertical direction, what we're saying is Fn plus Fg, or minus Fg as the case may be, because they're in opposite directions, and that equals 0. So we're saying Fn is equal to Fg. We're not going to worry about it. In the horizontal direction, what we can say is this. We can see that we've got so again, F net equals the sum of the forces. And in this case, the sum of the forces is, it's going to be, so if I make this direction positive, let's make this direction positive and this direction negative. So to the right is positive. What we have is 250 newtons plus 300 newtons minus 500 newtons. And what I'm left with, F net, is equal to 50 newtons. And that's positive. So it's implied because it's, when you subtracted it, becomes positive, and that means the net force is equal to 50 newtons to the right. That's what the positive means. The plus and the minus are just there to describe a direction, basically. So that's how you would do these questions in one dimension, where it's either back or forth. Everything can be described using sign conventions.